Here we're going to continue graphing using x and y intercepts, but we're going to apply it to real-world situations. This will show us how the line that we're graphing will help us gain more information about the problem. First problem we're doing talks about helping to plan an awards banquet for our school, and we need enough tables to seat 180 people. Tables come in two sizes at U-Rent. Small tables seat 4 people, and large tables seat 6 people. We're going to let x represent the number of small tables we have, and y represent the number of large tables we have. I can also see that my axes are labeled similarly. X-axis is small tables, y-axis is large tables. So the first thing I'm going to do is I'm going to draw a visual of the situation. So here might be my small tables. I don't know how many of those I'm going to have. And at each one, I want to show that I have 4 people. I could put stick figures, or I could just put 4 dots around to show that. And what this is showing me is that every time I have a small table, there are going to be 4 people sitting there. Then I could have my large tables. So I want to draw them a little bit bigger. Again, I don't know how many of these I have, but this time I'm going to have 6 people around each large table. And the reason I need different variables, x for small tables and y for large tables, even though they're both tables, I could have one number of small tables and then a different number of large tables. So my equation to represent this situation, knowing that I'm trying to seat 180 people, would be 4x. So I would multiply the number of small tables by 4, because there's 4 people per table. 6y, the number of large tables, which I don't know, times 6, because there's 6 people per large table. I would add those two things together, and that would get my total of 180. And so now I'm going to graph this using x and y intercepts. So I've got my intercept table here, and I'm going to use this equation. So remember that when we're finding our x-intercept, that means it's going to be along the x-axis, which means I don't want to go up and down at all. And the only way that I'm not going to move up and down is if my y-coordinate is 0. So I'll do my x-intercept work over here. So in my equation, 4x, I'm going to change y to 0, which would give me 4x equals 180. And then I'm going to divide by 4. I could do that in a calculator, or I could divide by 2 twice, since I don't have a calculator available. So I know that 180 divided by 2 is 90. And then if I divide by 2 again, that's going to get me 45. So I'm going to come over here and graph that point 45, 0. Now I'm going to do my y-intercept. And so if it's going to be along my y-axis, that means I don't want to move left or right at all, which means I need my x-coordinate to be 0. So in my equation, I'm going to change x to 0 and solve this for y. Divide by 6, and 180 divided by 6 is 30. And so now I have my x and my y-intercepts. My next step that I'm going to do is I'm going to graph the x and the y-intercepts using a line. I'm also not going to bring that line beyond the first quadrant, which is all they're showing me anyway. Because as soon as I extend my line into this region over here, that means the x values are becoming negative, which means I would have negative small tables, which doesn't make sense. And as soon as I extend my line down here, my y's would be becoming negative, and I can't have negative large tables. So it's important to know that this line is just a segment that only extends between my 2 intercepts, which normally is not how we graph, but in this case it is. So let's say you were to call the rental company up and tell them what you need, and they say they can help you, but maybe that they're out of small tables. So if they're out of small tables, that means that you have 0 small tables. So that would mean that you would need 30 large tables. So that's kind of the significance of that y-intercept. What that's saying is x, which is small, is 0, y, which is large, is 30. So we're saying 30 large if there are no small. And the other one is saying, what if there are no large tables? No large tables would mean we have 0 large, and so that's my x-intercept on my graph. And for that one, I would need 45 small. And so that's the significance of my x-intercept. So these 2 points are possibilities. It just means that at my y-intercept, I'm using all large tables, and at my x-intercept, I'm using all small tables. So then we're going to find 3 possible combinations of small and large tables that we can use. This is where it's really important that you've graphed your line using a ruler. If you've just kind of sketched it freehand, you're probably going to have trouble coming up with these combinations. So I already have 2. I have these combinations here, which I'll fill in my table in a second. And then I can use my graph to find some other combinations, but I'm also going to check it using algebra. So for example, I see that this point right here certainly looks like a pretty good option. So I'm just going to put a dot there. And then I'm going to write its coordinates. So that point has an x coordinate of 30 and a y coordinate of 10. So 30, 10. So it looks like if I had 30 small tables and 10 large tables, that would get me 180 people. But I would check that by using my equation, because remember, if I have 30 small tables, that's going to be 4 people per table. That would be 120 people. And if I had 10 large tables at 6 people per table, that would be 60 people, and that would in fact give me a total of 180. So one of my combinations that I just found was 30 small and 10 large. See if you can find another one along this line. But what's important to make sure about is that whatever numbers you think you find, that you plug them in to the equation and make sure they equal 180 total. So pause the video, see if you can find one more. Press play when you're ready to check your answer. So one for me that I think I might have found is this point right here, 15, 20. That's right here. Now, if you actually look at those gray grid lines where they cross, my line actually doesn't go through that. But I'm not sure if that's just because of how I drew my line, and again, I'm going to unexplain everything. I'd be more accurate with the paper and pencil ruler, or if it really doesn't pass through. But it certainly looks like 15 small and 20 large might be an option. And so I'm going to check that, which seems pretty close, 15 and 20. And I'm going to do what I did before. And so whatever point it looks like you might have picked, whatever this number is here, that's your small tables, and we know there's 4 people per small table. So for me, that would be 4 times 15, which is 60 people total sitting at the small tables, and then 6 times 20, because that would be 6 people per table at 20 large tables, and those would in fact add up to 180. And so it's important that no matter how close your point looks like it's on this line, you always want to double check and make sure that when you plug it in, that it works. Another important consideration to know is that, for example, like this point right here, and I'll use a yellow dot to show it, say like this point right here, that's a point on the line that I've drawn. But if I were to go down this way, I know that this y or x coordinate is somewhere between 5 and 10. But I'm not sure if it's 8, I'm not sure if it's 9, I'm not sure if it's 8.5, and clearly 8.5, I can't have 8.5 small tables. So there are some options in between here, but what I'm really looking for that's going to help me is where these points or where this line crosses at these grid lines, because then I'll know for sure that I have integer coordinates. And so I've got 2 of my possibilities so far. I could also write in here, I could put in, for example, my 45 small, 0 large, or I could even put in my 0 small, 30 large. So on this next example, we are making and selling decorative bows. We're selling small bows for $3 and large bows for $5, and we want to earn $60. One thing that comes up often when doing this problem is, well, it would be okay to make more than $60, right? Yes, in real life that's true, but for the purposes of this problem, we're going to pretend we want to make exactly $60, no more, no less. So when we get down to part B, we're going to represent that using an equation. So the first thing I want you to try to do is to draw a visual representation of the situation. So remember, before we were drawing small tables showing 4 people at each table and large tables showing 6 people at each table. Here you should be drawing some type of small bows and large bows. So pause the video to draw your picture, press play when you're ready to check your answer. Okay, so I tried over and over to draw some bows. It didn't go well, so I finally had to Google some images. So I've got my small bows that are $3 each, and I'm showing that I'm buying an unknown number of them. My large bows that are $5 each, and I'm buying an unknown number of them. And then I accidentally went ahead and wrote my equation as well. And so my equation would be 3x plus 5y equals 60, because it's $3 per small bow, which is x, $5 per large bow, which is Y. I'm going to add those two amounts of money together, which would get me my total money. Remember that word per or each, when you think about it, is, even though that word doesn't show up in here, you could always think about it as $3 per or $3 each, and that's going to mean to multiply. So now what I want you to do is I want you to take this equation and I want you to find your X and Y intercepts, graph, and connect with a ruler. Pause your video, plus press play when you're ready to check your answer. So for my x-intercept, that means I change y to 0, and then I solve for x to get 20. For my y-intercept, I change x to 0. I solved for y to get 12. Remember, when you connect these, you don't want to extend into the negative quadrants because you can't have negative bows. So let's say you decide to sell these bows, but you decide to only make either small bows or large bows. So if you only decide to make small bows, that means you're making 0 large bows. So how many small bows would that mean you would need to make? That would mean you would need 20 small bows. 20 small bows if 0 large, because that's what that ordered pair 20, 0 represents. X is the number of small, Y is the number of large. And vice versa, if you're only going to make large, that would mean that you would need 12 large if no or 0 small, and that's represented by our other intercept, which is 0, 12. So now what you're going to do is you're going to use this graph, just like we did before, to find some possible combinations of small bows and large bows that we could sell. It's also important that whatever you find for your ordered pairs, that you also make sure that total amounts of money add to $60. Find those combinations, see if you can come up with 3. If not, try to get at least 1, maybe 2. Pause the video, press play when you're ready to check your answer. So on my graph here, I've got 3 possible, what I think might be possible combinations of small and large bows. Now these 2 points here aren't exactly on my line, but remember last time I got close. So I want to check these algebraically. We'll see that in a second. This one right here, 10, 6, looks pretty good. So I want to check that one first. So I'm going to check that ordered pair 10, 6, which is XY. So that means 10 small at $3 each, that would be $30. 5 large at $5 each, that would also be $30. And so that would add to 60. So yes, that's a combination, 10, 6. Now one of my other ones was 14, 4. So at $3 each, that would be 42. At $5 each, that would be 20. And so that does not add to 60. So that one actually doesn't work. And then the other one I was checking was 6, 8. At $3 each, that would be 18. At $5 each, that would be 40. And that adds to 58. So that's actually also not a combination. So again, it's important that even if your points, like on yours, this might have landed on the line, but sometimes we're not super precise. Maybe our ruler moves or something like that. So you want to always check algebraically. So I could actually only find 1 additional combination besides my 2 intercepts, which were 20 small and 0 large and 0 small and 12 large. Okay, so our last thing on this problem that we haven't seen in a while, but we're going to bring back, is domain and range. So if you remember, domain is all of the possible inputs. It's like a list of all the things that can go into a function. And the input in a function is the x value. Now remember, in this problem, the x value is the number of small bows. So what we're trying to communicate here is all the possible amounts of small bows that we could make. On the left side, we're going to have our minimum number, and on the right side, we're going to have our maximum number. So the minimum number of small bows that we could make is 0. The maximum, if I go back to my graph, would be how far to the right my graph extends. And I'm going to make the maximum number of small bows when I don't make any large bows. So that number is going to be 20. And so what that's telling my reader is that I could expect to make anywhere between 0 and 20 small bows. It can't be less than 0. It can't be more than 20. For my range, that's going to be my y values, or all of the possible y values, which is all my possible numbers of large bows. I'll put my minimum and my maximum. So my minimum would be 0, and my maximum on my graph would be the highest that my graph reaches, which would be 12. So my maximum number of large bows would be 12.